Okay, so on page 40, and number 2, this is 2, 6. Now, what we're asking is find the rule vector rules for computing this. You can't compute this because this matrix right here has 3 rows, 1 column, and this one has 2 rows, 1 column. And you can't multiply that. These two have to be the same in order to columns in the first have to equal the rows in the second, and you cannot do one with function. So that's the problem with that one. So the next group of problems 5 through 8 says use the definition of AX to write the matrix equation as a vector equation. So 6. Make sure I get all my signs to everything up. So that one is a matrix equation. If we wrote that as a vector equation, it's going to have to be, this number right here is going to have to be multiplied by this vector. That's because if you multiply this out, you're multiplying these two, this times that, you'd have minus this row times that column. So you get 7 minus 2 minus me times 5. And then this row times that column, that row times that column. So then when you get done with it, the 2 comes out of this vector and 5 will come out of that vector. Running from matrix to vector. So that one, you want to write a matrix form. So what you're going to do, 3, 4, mine is supposed to be up there. -4 and 5. 5 and 4. And 3 and 4. And then the C1. And they'll be going from the vector form back to the matrix form. 9 and 10 says write the system first as a vector equation and then as a matrix equation. That's just a system of linears. So the first thing you want to do is write it as a vector. So it's going to be x1 times this row. Then you go plus x2 So it gives you an idea of what you're doing when you're doing all these matrices or vectors. It's actually just simultaneous equations. That's all you're doing. And then as a matrix form, or a matrix. And just, verify you've done it right. This is 3 columns, 2 rows, 2 columns, 2 rows, 1 column, 3 rows, 2 columns, 2 rows, 1 column, gives you these two have to be the same, gives you a 3 by 1. So this always has to be doing these two are going to be the same. You can't do multiplication. And if you multiply it out, you get right back up here. So the next problems are going to say, write the augmented matrix for the linear system that corresponds to the matrix equation AX equal B, then solve the system and write the solution as a vector. given these A's. And then you want to write this as an augmented matrix. So then we're going to do 1 minus 3, 0, 2, 1, 1. Is that a 5? And then the augmentation. That was 3, okay. This was 3, right? Okay, we got and it says solve the system. So the easiest thing to do to solve it is just get a reduced echelon. It's going to work. So I'm going to just do the first row. Then I'm going to take positive 3 from the first and add it to the second. Makes this, because I'm going to make zeros. Positive 3 up here, 6, 1, 7, positive 3. And then 2 is positive 3. And then the next one, just put this down. Now, it's what you want to do with that. What would you want to do next?
Shouldn't the second be a 5?
Should I do something? This should be a 5?
Yeah.
That would be helpful. I'll blame you on my phone. Now did I do it right?
And the top. And this would be minus
9 is 5. Because, no, it's a plus 5.
So that should be minus 1.
But this is supposed to be minus 1.
Yeah.
I made a mistake right here. Is that right?
Yes.
So now, then when I do 2 times 2 is 6, then this becomes minus. Now we good?
Should be 5.
It's 4 positive, because it's 3 times 2 is 6 minus 1 is 6.
This is 6. This is a plus 5. Now what? Huh? What do you think? Divide the middle row, row 2 by 5 to get 1. It gives that, or else you can subtract that row from the bottom. It's whichever way. What do you want to do? You want to subtract row 2 from row 3 and then do our division. That's a -2. That's a -2. Is this going to have a solution? Has a pivot point underneath zero. Okay. It's, you know, the augmented. When I do the reduced echelon, it will have a solution. And this is 1/5. Right? Now I can divide this by -2. Now what do I have to do? I got to start in this column and get 0, right? So 1, 2, and then minus, this is going to be minus. I'm going to make this 0, minus 1, and subtract this one from that one, so I got 0, 1, 0. So this is actually a -5/5 plus 1/5 is a -4/5. Plus minus 0. Now what do I got left? That one right there. So I'm going to take -2 times this, combine it. -2 times that is a plus 8/5. This is going to be a -5/5. So that's 3/5. Is that right? Now, what are they telling me to do? I know what this. Which number am I on? 12. Solve the system and write the solution as a vector. Here's the vector. I've written my solution as a vector. It's a vector. And it's the vector for x1, x2, x3. So, any questions on that? All right, the next one we'll look at is 14. It says that u equal 2 minus 3, 2 A of the matrix is U in the subset of R3 spanned by the columns of A. So if you look back at theorem 4, what would you do? Could we take that matrix A, make it in echelon form, and see we've got a pivot in every row? Because it says back there, that D, it says A has a pivot position in every row. Then you know, for each B in Rm, the equation Ax equals B is the solution. All right. I'll just do a part of the matrix. I wouldn't have to do this, but I could do this. It's mainly this part. What would you do with that? To do it in echelon form, to make it as easy as maybe possible. I interchange row 3 with row 1, right? Because then I have a 1 over here. And I have a 1 in the second row. And we'll have 45. And then it just, I'm going to take -5 times that first one. And we'll add it to the last one. Zero. That's a -15 plus 8 is that a -7? Is that right? I'm just leaving that ornamentation off. Now, I want to get rid of that -7. So I'm going to 7 times this, add it. 7 times that, add it. What do you think? question is U in the subset of R3 spanned by the column A? Why or why not? No, because why? There's no pivot position in U. That says X3 is free. There's no pivot, so there's no switch. That's theorem 4, last one. Okay, the next one I want to do is 16. It says to repeat exercise 16, but only it says repeat 15. A is the matrix, I'm just reading 15. B is B12. Show that the equation AX equal B does not have a solution for all possible B, and describe the set of all B for which AX equal B does not have a solution. 16 says just repeat that process. So, how are we gonna, what are we gonna do with this? Augment the matrix, get one some reduced echelon form, and then see what those B's look like. So we're going to have to take this. Right here. Thanks. So we leave it kind of the way it is, just do reduced echelon form. So add three times the first and add I multiplied it 3 times that, didn't I? I was going to put minus 1. I thought about it. Okay, and now it's going to be -5. I do that last one right, at E3 minus 5B1.
I think that's right.
If I took 2 times this before I divided that out, it would get rid of this one and it'd make that 0, right? And then I'd have 3. I'm going to leave this. Now I'm going to take 2 times that second row and try to get rid of this 0, and it gets rid of this. And then I take 2 times this. So I'm going to put this down first. 3 minus 5. I'm taking 2 times, just a straight 2, plus 2, so what has to be true? In order for the solution to exist, that has to equal 0, correct? So, 3 minus 5, 1, I'll run that 2, 2b2 plus 6b1. So I simplify this as b3 plus b1, 2b2. So it's a vector going through the origin with b3 plus b1 plus 2b2. If I get it right. You'll make sure to do it right. Good. It's giving you a couple matrices of their A and B. It says, do the columns of B span R4? Does the equation Bx equal Y have a solution for each Y? So, if you look back at theorem 4, what would you use then for the term columns of D span R? Notice in column 4, it says C, it says the columns of A span Rm. So if you show any of those other three, you can say that B, spans R. So what are you going to use? Show that. What's that?
You use reduce echelon form.
Yeah. Well, could you use D where it says A has a pivot position in the row? So just echelon form. If it has a pivot position, then and that's what you said. That's what you said. You see that? So if B, if you take matrix B, you put it, like you said, in echelon form, and you find the pivot, you don't even have to go to reduced echelon. Okay? All you got to do is go to echelon form and make sure there's a pivot in each row. If there's a pivot in each row, then that matrix spans it. So we want to go through and practice in echelon form. Sure. So what I'm going to do is I'm going to take D. Did I do something? Where? Well, I think I'm going to leave it the way it is and just get zeros in the first column. So I'm going to take 1 minus 1 times the first and add it to the third. And then we'll take 2 times the first, add it to the So I got pivots in first row, second row. So I'm just going to get zeros down below the second column. Just like 1 times the first and add it to this third, 1 times the second. vector 2. We're going to get a pivot in the middle. And this one is 18. So we conclude, does the columns of B span R4? No, right? Does equation bx equal y have a solution for every y? No. And the theorem proves. Let's look at 22. So it says let V1 equal V2, V3. Does V1, V2, V3 span? So what would you do with that? You wrote that in that as a matrices. Check and see whether it had pivot points in every row. And that would tell it, right? So those are vectors, so we'll just write it in matrix form. Is that a 6 minus 2? And then we'll just check pivot points. So what I'm going to do is take the first row, put it in the third row position.
I think that 6 is supposed to be a 0.
Did you say something?
I think that 6 is supposed to be a 0.
This was supposed to be a 0?
Yeah.
Thanks. So if I just flip it, right? Minus 2, 8, and minus. And then flip it. That is a pivot point in the row. Right? So we would say that those vectors span R3. Somebody's pretty. I'm gonna give you just wait, I'll talk to you. I got a quiz. But